Hello friends, in today's question, two blocks connected a massless string slides down an inclined plane having an angle of inclination 37 degree. The masses of two blocks are m1 4 and m2 2 kg respectively, and the coefficient of friction of m1 and m2 with the inclined plane are 0.75 and 0.25 respectively. Assuming the string to be taut, find the common acceleration of two masses and the tension in the string. So we have inclined plane, two masses m1 m2, and they are connected to the string, and they have different coefficient of friction, and m1 is 4 and m2 is 2. So we have to find out the common acceleration and the tension in the string. So let's draw the free body diagram for individual masses. Say for mass m1, it is in inclined plane. Let us suppose this is theta, which is 37 degree, and we have mass m1 moving in the downward direction with the acceleration a. So we are going to have m1g. It can be divided into two components. This will be our theta, so this will be m1g cos of theta, and this will be m1g sine of theta, and also there will be a tension T. As it is moving in downward direction, the frictional force, that is Fr1, will be acting in opposite direction, and we are going to have a normal. Let us call it n1. So we can say our Fr1 will be equal to mu1 into n1, and n1 is m1g cos theta. So we can put our Fr1 is equal to mu1 m1 g cos of theta. Now we can write the equation of the motion, which will be coming as m1a is equal to, it will be t plus m1g sine of theta, and minus Fr1. We substitute the value of Fr1, we get this as m1a is equal to t plus m1g sine of theta minus mu1 m1g cos of theta, and let us call this as equation number 1. Similarly, we write for mass m2. This angle theta, and we have mass m2, and m2g vertical downward. It's two component. One is along the inclined plane, and another one will be perpendicular to inclined plane. So this will be theta. So we have m2g cos of theta, and this will be m2g sine of theta. There will be tension T, and as it is moving with the same acceleration a down the inclined plane, so we are going to have a frictional force, let us call it Fr2, in the upward direction, and there will be normal, let us call that n2. So we can write the equation for the frictional force Fr2. Fr2 is equal to mu2 n2, and n2 is m2g cos theta. So we get this as m2g cos of theta. So for the equation of the motion for mass m2, we are going to have m2a is equal to m2g sine of theta minus t minus FR2. We substitute the value of FR2. We get this as M2A is equal to M2G sine of theta minus t minus mu 2 M2G cos of theta. And let us call this as equation number 2. Adding 1 and 2. T cancels out if we add 1 and 2. Adding equation 1 and 2, we get on the left side it will be M1 plus M2. A will be common, and on the left side we have G sine theta will be common, so this will be coming as G sine of theta M1 plus M2. Minus t and plus t cancels out, and on other part we are going to have minus G cos of theta is common, and we are left with mu1 M1 plus mu2 M2. We substitute the values. M1 is given as 4, so this will be 4 plus 2 multiplied by A, and we have G, and let us suppose this 37, so this will be 2 plus 4 minus G cos of 37, and mu1 is 0.75, M1 is our 4 plus 0.25, M2 is our 2. So we can write that our acceleration A will be equal to G, and we know that we solve this, G can be taken as common, so this will be coming as 3.6 minus 2.8, which will be equal to 9.8 multiplied by 6 divided by 6. Therefore, the acceleration A will be coming as 1.27 meter per second square. So this is the common acceleration of two masses. This is the common acceleration of two masses. In the B part, we are supposed to find out the tension in the string. So we are going to use equation 2. Okay. So you can say from equation 2, we can write this as T is equal to M2G sine of theta minus mu2 M2G cos of theta, and that will be minus M2A. Substitute all those values. So T will be equal to M2 is our 2 kg, G is 9.8 sine of 37 minus mu2 is our 0.25, M2 is 2, 9.8 cos of 37 minus, and we have 2 kg and acceleration is 1.27. So we are going to get this as T is equal to 11.76 minus 3.92 minus 2.54. So simplification gives us T is equal to 5.3 Newton. So this is the tension in the string. This completes the question. Thank you.